Number 6 of exercise 5.2, integrate the definite integral 0 to pi by 2 tangent x ln sine of x dx. That will be equals to 0 to pi by 2. Tangent x can be written as sine of x over cos of x ln sine of x. Now we know that sine of x, this can be written as cos square of x plus sine square of x equals to 1. So sine of x will be equals to 1 minus cos square of x under root. So we can replace it with this value 1 minus cos square of x dx. Well, now we need some substitution here. Let z equals to cos of x. So this implies dz is equals to minus sine of x dx. We have here sine of x dx, so just move this negative sign this side. We'll get minus dz is equals to sine of x dx. We know that we have some limits of integration here. So if we are just substituting some other function here, so we need to convert this limit of integration into that function. The limit is x, the limit is on x, but now we are converting our function into z. So it means when x approaches to 0, this lower limit, then if I put 0 here, then z will approach to 1. And if I apply the upper limit, if x approaches to pi by 2, cos pi by 2 will give you 0, then it means the z approaches to 0. So our limits of integration will convert into from 1 to 0. It will become, now apply the substitution in that, we will get limits of integration. On the lower limit I got here 1 and on the upper limit I got here 0. It will become 1 to 0. Sine of x dx, this will be equals to minus dz. So negative sign I have taken outside and this will be written as dz. Ln 1 minus cos square of x, this will become ln 1 minus z square divided by cos of x is z here. It can be now solved as, you see, the lower limit is greater than the upper limit. We can just reverse it. After reversing it, this negative sign will be cancelled. So we can write it like 0 to 1. If we just reverse the limits of integration, we will just write the negative sign. That negative sign and this negative sign combined will become positive sign. And we know that this is the property of ln. If we have ln x raised to power n, this power can become down here in the coefficient of ln. So the power here is 1 by 2. This 1 by 2 will be written as the coefficient of ln. So I have taken it outside. It will become ln 1 minus z square over z dz like this. Now 1 by 2, 0 to 1, 1 over z into ln of 1 minus z square dz. ln 1 plus x. This has the sequence 1 x plus x square over 2 plus x3 over 3 plus up to so on. So we can just replace it with this as well. It will be easier to integrate it. It will become 1 by 2, 0 to 1, 1 over z into. Now here in place of x we have minus z. So it will become minus z square, this is z square, minus z4 over 2 minus z6 over 3 and minus up to so on dz. Now it will become 1 over 2, 0 to 1. Multiply z inside, take the negative sign common. It will become z square, this thing, this z and z will be cancelled. So we will be left behind z plus z cube over 2 plus z5 over 3 plus up to so on dz. Now integrate it. It will become minus 1 by 2. Integration of z will be z square over 2 plus z4 over 2 into 4 plus z6 over 3 into 6 plus up to so on, and the limits of integration are from 0 to 1. First I am simplifying this, then I will at the end apply the limits of integration. This thing can be written as, this will be equals to negative 1 by 2. Now I can take this 2 common out of here because it is coming in every denominator. So I am taking 2 common outside. In the left inside I will be left behind z square over 1 plus z 4 over 4 plus z 6 over. If I take 2 common here, I will be left behind 3 here. So 3 into 3 will give us 9 plus up to so on, and the limits of integration are from 0 to 1. It will become minus 1 over 4, and here I can write it like z square over 1 square plus z square over 2 square plus z cube square over 3 square plus up to so on. And the limits of integration are from 0 to 1. This can be evaluated as minus 1 over 4, and it can be written as pi square over 6 after applying the limit. I will get minus pi square over 24 in my answer. Now the question arises here, how I got from this step to this one. You know that the upper limit is 1 and the lower limit is 0. If I replace this whole thing with the upper limit 1, I will get 1 over 1 plus 1 over this 2 square plus 1 over 3 square and up to so on. And with the negative sign, if I apply 0 in this, all this, I will get 0, 0, 0 and up to so on. And combine, I will left behind with 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus 1 up to so on. And this thing, you know that it is an identity and it is equals to pi square over 6. So that is the reason I have directly wrote it here, pi square of 6 after applying the limit. And it will be minus pi square over 24 in our answer. Now move on to the question number 7. Integrate from 0 to 2 pi dx over 5 plus 3 cos of x. This will be equals to, we know that in your book you are given with a theorem at page number 177, this 5.11 part 1. We know that if f of x equals to f of 2a minus x, you see here you have cos of x and the limits are 2 pi. If you replace your cos of x with cos of 2 pi minus x, you will get the same answer. It means you can break this integral as using this theorem. If your function is the same as you replace it with the upper limit minus x, then you can just replace your integral with this function, this second integral. And what is that integral? Just divide your limit of integration with 2, you will get a here. With 2a divided with 2, it will give a here, and write 2 in the coefficient of this integral. So using that theorem, I can write it like the 2 in the coefficient, and your upper limit of integration is divided by 2, so it will become 0 to pi, and the denominator will now become dx over 5 plus 3 cos of 2 pi minus x, like this, by using theorem 5.11 part 1. That is on page number 177 of your book. Now, this integration, you can just memorize its direct formula as well after this step. Let me tell you. 2 to 0 to pi dx over 5 plus 3. You know that this thing is equals to cos of x. And how, from where you can conclude this? Using this formula, that is cos of alpha minus beta is equals to cos alpha cos beta plus sin alpha sin beta. Using that formula, just replace it with 2 pi and this with x. You can see that you will get cos of x now. Now this integration is the lengthy one integration, and you can just memorize its formula as well. You can directly use it here because this exercise is emphasizing on breaking this limits of integration, not on the integration process. So you can memorize its direct formula as, let me write it here. If you have the integration dx over a plus b cos of x, this will be equals to 1 over square root a square minus b square, absolute value of cos inverse a plus b cos of x over a plus b cos of x, like this. This is b plus a and this is a plus b cos of x. This is b plus a here over a plus b cos of x. This is the direct formula for this integration. You can just replace it with, we'll get 2 into 0 to pi dx over 5 plus 3 cos of x. Now replace it with this formula, we'll get 2 over this thing, that is a is here 5 and b here is 3. So you got here 5 square minus 3 square, absolute value of cos inverse 3 plus 5 cos of x over 5 plus 3 cos of x, and the limits of integration are from 0 to pi. Now apply the limits of integration. We will get now you can apply the limits of integration. This will be cos inverse, applying the upper limit first. Cos pi is equals to minus 1 and cos of 0 is equals to 1. So if I apply the upper limit first, I will get cos inverse 3 minus 5 over 5 minus 3. Then negative sign of the formula and apply the lower limit. I will get cos inverse 3 plus 5 over 5 plus 3, like this. Now evaluate all these terms that can be simplified easily. I will get 2 over 5 square is 25. 25 minus 9 will give you 16. And if I take it outside, I will get 4. So it will be 2 over 4 into cos inverse. This will be minus 2 over 2 minus cos inverse 8 over 8. So I got here 2 over 1 over 2. Here I got 1 over 2 and cos inverse of minus 1 minus cos inverse of 1. You know that cos inverse of minus 1 you can get easily out of here. This is pi, and cos inverse of 1 is 0. So I will get 1 by 2 pi minus 0, that is equals to 1 by 2 pi, or you can also write it like pi by 2 as well. Question number 8, that is 0 to 1 tangent inverse 2x minus 1 over 1 plus x minus x square dx. Let's suppose this is equals to I, some other integral name. You can just name them as well. I is equals to 0 to 1 tangent inverse 2x minus 1 over 1 plus x minus x square dx. You know that in your book you are given with a theorem on page number 176, theorem 5.9. In that theorem it is written here, you can just break your function from 0 to a f of x dx as 0 to a f of a minus x. You can replace your function variable with limit minus that variable. Replace x with a minus x. So using that theorem here, I can write it like, my limit here is 1. So I can replace x with 1 minus x. So using theorem 5.9, and that is on page number 176. I will get here I equals to 0 to 1 tangent inverse 2 into, in place of x you have to replace it 1 minus x divided by 1 plus 1 minus x whole square, that is dx. Open all these terms, you will get 0 to 1 tangent inverse 2 minus 2x minus 1 over 1 plus 1 minus x. This thing will be opened as 1 plus x square minus 2x using the formula of a minus b whole square. Now open this bracket and you will get I equals 0 to 1 tangent inverse 2x minus 1 over, this is 2 minus 2x minus 1, 2 minus 1 will be your plus 1, 2x plus 1 divided by, you can write it like 1 plus 1 and that negative 1, after solving you will get 1 plus x minus x square dx here. Now I can take negative sign common out of here because I see here I can make it the same with the question, make it as it is. The denominator is same as in the question, but the numerator is opposite sign with that question sign. So I am taking negative sign common out of it. I will be left behind minus 0 to 1 tangent inverse 2x minus 1 over 1 plus x minus x square dx. Now you see this is the same as your question. It is the same thing. So you can replace it with I. So you are now it will become I plus I equals to 0. 2I equals to 0. So I equals to 0 over 2. So you got I equals to 0. So your determinant is solved from 0 to 1 tangent inverse 2x minus 1 over 1 plus x minus x square dx equals to 0 here.